In the previous lectures, we have derived many formulas for step-graded junction. Now, we are going to analyze different formulas for linearly graded junction. Concentration profile is shown in the figure, which can also be represented as here. Alpha is impurity gradient factor. Now, by Poisson equation, we have electric field 2 equal to here C1 is a constant of integration. We know already that the electric field is 0 outside the depletion region. Therefore, we can find the value of C1 by setting E is equal to 0 at any point outside the depletion region, but for reference, we will take the distance x at the boundary of the depletion region of the p-type, which is x is equal to minus w by 2. Therefore, we can write electric field to be equal to we also know that potential is given by after calculations, we will get the potential to be equal to C2 is another constant of integration. As we know already that the absolute potential is not important. The important parameter is potential difference across the depletion region. Therefore, we can arbitrarily set electric potential at x is equal to minus w by 2 to be equal to 0 and can find the value of C2. After finding the value of C2, we can write the equation of potential difference across the depletion region to be equal to we know already that the contact potential V0 can be found by putting the value of x equal to W by 2 in the equation of potential difference Vx. This will be the final expression for built-in potential. You can rearrange this equation to find depletion width in terms of built-in potential. Make sure that you understand that in the linearly graded junction, we cannot apply xp into Na equal to xn into nd. This is not valid for linearly graded junction. We can find the exact relation between these four parameters by equating this area to this area. But for making the analysis easier, there is no need to derive that. Also, there is no need to learn the formulas which are derived in this lecture. The important thing is you understood the derivation. Because even if you understood the derivation of step-graded junction, linearly graded junction, and the equation of charge density can be provided, and further formulas can be asked, or maybe a different type of concentration is provided to you and you are asked to find the built-in potential. All you have to do is integrate the equation. I hope you got my point. Derivation is much more important than the direct formulas. However, it will be much better if you learn the formulas for step-graded junction.